Okay, good day, everybody. Welcome to the Weather Company podcast series from the Forecast Desk. I'm Steve Abelman, Customer Success Rep and longtime aviation weather forecaster and enthusiast with the Weather Company. So today we're going to shift a little bit away from standard meteorology to look at the impacts of volcanic ash to commercial aviation operations. Very little raises the concern meter of a pilot or flight dispatcher more than a potential encounter with volcanic ash. We know pilots can skirt around thunderstorms, we can prep the cabin for turbulence, but the only option with ash is realistically to avoid it. And the stakes are very high. An encounter with ash damages engines. There's many documented cases of that. And advisories from the Volcanic Ash Advisory Center or SIGMETs from local governments can block huge chunks of prime airspace, especially over oceanic regions. So in today's podcast, we'll discuss the improvements in detection and forecasting of ash and learn about the benefits TWC customers get when using our focused services. I'm going to hand it off to a couple of very senior meteorologists to introduce themselves, and they are lucky to have them with me today. So I'll hand it off to Stephen first. Good afternoon, rather.
Good afternoon. Hi there. Yeah, so I'm Steve Andrews. I've been in the aviation forecasting group for 20 years, basically since the inception of it. And volcanoes are definitely one of those unique things that keeps us on our toes and makes us unique as far as a forecasting company for an aviation industry that so desperately needs accurate ash forecasts. So I'm happy to do that.
All right, great, Stephen. Thanks. And Colin, good afternoon.
Thank you, Steve. Thank you very much for having me on. My name is Colin Toenjes. I'm a senior aviation meteorologist with the Weather Company. I have been in the field for over 25 years operationally. Currently, I'm assigned as an embedded forecaster within the operations center of a major U.S. airline.
Thanks, Colin. Colin and I go way back, so it's always fun chatting with Colin. So
very way back.
We're getting old, buddy. Anyway, so let's get into this. So let's start with detecting ash. So first of all, high resolution global satellite imagery has really changed the game and the ability to track a volcanic eruption and follow the progress of the ash and the dispersion of the cloud. So I'll ask you both, how does TWC use this information to monitor and forecast volcanic ash?
Well, basically what we're utilizing is we're able to monitor when we detect an eruption or understand there is an eruption. We can look at those areas utilizing that high resolution satellite imagery, and we can use a bunch of different tools, not just visual inspection during the daytime, but also there are filters, algorithms, if you will, on that satellite imagery that have been developed to detect specifically the signatures of volcanic ash and sulfur dioxide, SO2, which is a major component of volcanic eruptions and is also a way to track things. We've also seen other things like at nighttime, since visual detection isn't available, we've found that actually a particular kind of algorithm, a filter that we use to monitor low clouds and fog, because it's based on temperature primarily of the cloud, is a very good tool for detecting volcanic ash at night, because it shows up with somewhat of a very brilliant signature. And that can be very useful, especially if you're dealing with a volcano close to a major airport, so you can see exactly where that is at night where visual detection wouldn't be available.
And to build on what Colin is saying is that when you combine the satellite imagery, which is so high definition now and so real time, we can literally get images within like 20 minutes of the real time that they occurred. And so with that current information, then you throw in webcams and of course current PIREPs, we can put all those together and really come up with a really good idea as to where the ash is visually and spatially in relation to not only the volcano, but then to any terminals that are nearby.
Yeah, it's really something. It really is seeing some of the imagery and seeing how clear some of the ash is now. So let me shift to another question in another area that I think is really relevant for TWC. So the Volcanic Ash Advisory Centers and local governments use dispersion modeling and other wind forecasts to create their advisories and SIGMETs. And we have access to these same products that are available and leveraged by TWC. But what differentiates our products from some of the government products?
Well, I mean, we provide a level of detail that the government can't necessarily get into because of we catering specifically to our customers and issue SIGMETs to let the customers know that these are the areas to avoid, but it's okay to go around them and just keep operating. So we don't try to block up as much space as the government does. We try to be more particular with what we're blocking off so that our customers can continue to operate in one way or another, whether it be by routing around or by looking at our information and making better decisions instead of the broad-brushed approach that the government takes.
And I'll refine to that. We do, again, try to be a little bit more specific on it. Sometimes they will block out an entire area around a volcano for something that is a relatively small plume. We can look at this and put in a little bit more of a detailed analysis of it, which is extremely useful for someone like myself as an embedded meteorologist. When you're dealing with a dispatcher or an operations manager that has a question about a particular volcanic eruption as to where it's going to affect them as far as routings, or especially for volcanoes that are really close to stations like Popocatépetl in Mexico City or Fuego for Guatemala City. If you've got an aircraft that's inbound to one of those and the dispatcher needs an immediate answer, it's not like they can particularly necessarily get that directly from just a broad SIGMET or from the VAC. But with us being embedded, we can show them what we are seeing. We can show them the data that we are using, and that'll allow them to make a better decision. We can communicate that risk so that they can make the better decision, especially when you have a situation where they're deciding whether or not to divert an aircraft or not.
Thanks, Colin. Yes, I've seen that plenty. And there are several sets of embedded meteorologists throughout TWC in airline operations centers. So one follow-up question to that, though. So when we can no longer see the ash, what do we do next?
Typically, when the ash is no longer visible through any of the satellite means or webcam imagery or whatever we have available, which can be difficult sometimes with the detached areas of ash, but once we can no longer really detect it, it's generally going to be at levels where it's going to be it should be safe for operations. Now, you may smell it, for example, SO2, sulfur dioxide, smells like rotten eggs. And so sometimes you will detect the smell, but the ash concentrations at that point should be below what would be an impact for the aircraft. So we would stop issuing the SIGMETs at that point.
Yeah, basically, when it is one of these things that we'll track it pretty much as long as it's visible on satellite. We do reach a point that I think, though, then we'll make the decision if it's no longer a threat. And usually we try to do that as soon as possible so the customers can get back up and operating the way they want to. But we also just don't want to highlight an area that is just of a smell and not of a danger. And so with Colin being in the remote offices and talking to the dispatchers directly, they can actually assure the confidence that the forecasters that are up in Andover and the en route forecasters that are doing the volcanic ash predictions congruent with what the forecasters are saying in the remote offices when you compare them to what our products are saying. So it's a really good team effort as far as having the remote people to really answer the fine details of things, and then for us in the en route side of things in Andover to really kind of visually dictate what is going on to help them out.
Yeah, we definitely coordinate very closely between our teams and the forecasting teams in Andover and in the other offices.
Thanks, and you guys did touch on my next question, which is good, but I want to go back to it a little bit more. You mentioned Popo in Mexico, and you mentioned Fuego for these small, low altitude eruptions that don't necessarily impact anybody at altitude, but they can come very close to the airport. And I think you already talked about how you can help customers in this events. Stephen, was there anything else to add with these little smaller eruptions that maybe aren't such a big deal? Are you talking to customers occasionally about some of these smaller eruptions in Andover Center as well?
Yeah, we're definitely trying to keep the communication lines open. And so we have a couple of different products that pretty much help us dictate the importance of what's going on. And so usually we start with a PDF, which is a volcanic ash advisory per se that we issue that shows where our SIGMETs currently are and where the ash is expected in the next 6 to 12 hours. We have a detailed discussion that goes with that. But if an emission has been going on for several hours and it looks like a longer term consistent thing, There's another product that we have. It's a PVI. It's a potential volcanic ash impact product. And that actually extends 24 hours looking at the winds at the summit and tracking those winds if they're going towards any terminals of any concern that are in the close by area. So those PVI documents, like I said, are more long-term. They can lay out the risk of low, medium, and high as far as what a terminal might be impacted based on the winds at the summit height. And if that ash might eventually head toward the terminal or continue to stay away from it. So between the PDF in the near term and then the PVI in the long term, we try to give as big of a picture as possible for the customers to make long-term, like short-term and long-term decisions to continue to operate as efficiently as possible.
And we utilize those products as embeds also for communications purposes to the end users, to the dispatchers, to the management personnel, so that they can make those decisions. And again, we're also using a lot of real-time imagery, especially for places like Popo, where they have streaming webcams, which has been just an absolute, a complete addition to the forecasting process, because we can see in the daytime at least, are those clouds, or is that steam, is that ash, how thick is it? We can get a little bit more granularity in the data from that and the directionality, so we can give them better information to make decisions.
Thanks. Yeah, that's excellent stuff. Okay, here's the funnest question of the day. Eyjafjallajökull, which I'm probably not even close to pronouncing right, affectionately known by me as E15, was tremendously impactful and disruptive to global aviation. So if we have another eruption of this magnitude with this longevity, what do you think we've learned to do better now?
Well, I think for me, at least on the customer side of things, for the customer, the operation side of things, it's good to be aware what is possible and what can happen with this. Really, E15 was kind of the first major eruption of that scale and magnitude within the global aviation era, as it were. And so the question was, well, how possibly bad can it be? Now we know how possibly bad it can be, and plans can be made. Okay, if it's going to be like this is the adjustments that we can make. You're not trying to make them so much on the fly. You can actually have somewhat of a plan ahead of time, because it will happen again. I just hope that the next time it happens, it's something a little easier, a little less complicated to pronounce.
No kidding.
Yeah. I mean, it is interesting because we've gotten over a lot of the panic that a lot of these events have shown us, and more into the idea of preparing for the next one to happen. So we're definitely on a good stretch as far as like learning about those past events and how we can utilize that information to get the customers more detailed and up-to-date information that they can then utilize and get their operations going. I mean, things used to be so broad-brushed and we would block off a ton of airspace, but now we can get more specific, and that does help a lot as far as air travel continuing to get back to normal. So it's kind of a unique thing once we went through that one event, and like Colin was saying, we can see what's possible, but we're ready for what's possible when that next thing that happens is possible. So we'll be ready for the next big one, and we'll probably do a darn good job.
Thanks. And I'll add one thing, because I've seen it. The communication now has really changed too. There's a lot more communication between government agencies, between airlines, between the TWC, between a lot of different folks during an event like this. So I don't think there'll be as much surprise. So thank you for that. Well, this has been awesome. I want to give you both a little chance to make a closing statement, and we'll call it a wrap after that. So Colin, lead us off.
Well, I think that we've really seen this as a very big impact. Everybody kind of understands now what volcanic ash can do and does do. And that's something that, in the 25 plus years that I've been doing this, that's really changed. And it's been a constant problem. Popo has been active for all but I think 18 months of the time that I have been in the aviation industry. And so it's been a constant partner, a constant concern, a constant focus. And everybody really kind of understands now a lot better what that is. And I think we're well prepared to go into the future with helping to keep clients and keeping the aviation industry safe.
Thanks.
And, we have the different products. We have the SIGMETs that are right there in the near term that we issue right away. And then our PDF product is that 3 to 12 hour type of forecast. And then having, the PVI, which is the extended forecast, that, there's so many things now that we can do that we didn't necessarily know how to do beforehand. But the technology and the information has become so much more available in a tangible way that we can really make use of things and get an advantage over, per se, what the government might be doing, as we try to shine above everyone else and forecast this volcanic ash, which is really a fun thing to, not fun, but it's an interesting thing to do in this job, and I'm very happy to be a part of it.
Thanks. Well, I think great information exchange today, guys. Really appreciate your time. So we'll call this one a wrap, and can't wait to talk to you in another month or so. Everyone have a great day.